Hello, we are students from 2018 IBRC cohort, and we are here in Sorbonne University to test few effects of some nutrients and also herbicides and pesticides in phytoplankton productivity in the coast of Bagnols-sur-Mer. So these are some of the topics we're going to cover in this video.
On Monday morning, we went on board the research vessel Neresis of Sorbonne University to go sampling. A Nathan bottle was used to collect seawater on board. The Nathan bottle was deployed and opened using a pulley system at 2 meters in depth at the solar station. The water collected from the Nathan was poured into a 25-liter bottle. A acidity measurement was made to record the salinity, temperature, and depth of the samples. Here we could see the Nathan bottle being pulled back into the boat after deployment to be collected into a 25-liter bottle in order to be taken back to the lab for use in our experiment.
Okay, so now that we have our sample, let's start by explaining our experimental setup. We want to do some nice statistics, and thus we need some replicates. Hence, we work with triplicates of 1-liter bottles. The first triplicate is the one to relate to, our control treatment. These bottles were handled exactly the same as the others, but nothing was added, just our sample. Then we go into nutrients. We have a triplicate with extra nitrogen, one with extra phosphorus, and one with a combination of nitrogen and phosphorus. Finally, it would be nice to see the effect of a commonly used antibiotic, amoxicillin, used mainly in agriculture, and an herbicide, ergorol, which is often used as an anti-fouling agent on board boats, and hence will be present in the ocean. This experiment will take place over 6 days, with an initial sampling on the first day, then a second sampling on the 6th day.
So now we are gonna put the bottles into these nets, so to incubate them in natural conditions.
In an ideal world, we would measure nitrate, ammonium, and phosphorus, since these are the nutrients we added and are most commonly of interest when investigating primary productivity in the ocean. However, the scientist capable of measuring nitrate and phosphorus was on another cruise, so we only measured ammonium. So, we made a dilution series with a stock of known concentration of ammonium reactant in order to get an idea of the initial concentration and a final concentration of nitrogen in our samples. We want to know what will happen to nitrogen over time within our sample. Then, we ran our dilution series and our initial and final samples through a fluorometer to measure fluorescence. The fluorescence of the series of known dilutions was used as a calibration to calculate the ammonium in our samples.
So, remember, we want to test the effect of different nutrients, antibiotics and herbicides on phytoplankton productivity. Hence, we need a measure for phytoplankton biomass. Here, we will measure chlorophyll, the famous pigment that is quite good for giving a biomass measurement. We will also analyze another pigment called phaeophytin, which tells us something about the health status of the phytoplankton. We take measurements at initial time and final time of the experiment, which is after 7 days. And here you can see Savannah filtering our seawater sample through a 0.7 micrometer glass filter to collect phytoplankton. Oh, there it is! The phytoplankton was extracted from the filter using acetone. The acetone solution is now ready for fluorescence measurements. The calibration of chlorophyll A with fluorescence is done with a dilution series of known chlorophyll A stock concentration. With a simple equation putting fluorescence against chlorophyll A concentration, we are ready to measure our samples. Also, to estimate phaophytin, chlorophyll is acidified and converted into phaophytin. The higher ratio of phaophytin to chlorophyll, the more degradation there is in our water samples.
Good morning. Today we're at the harbor again and we are taking our first samples after 3 days. Now we are putting from our waters a little amount in tubes to later analyze in the lab bacterial respiration and enzymatic activity.
We have two experiments here.
Okay, let's stop Anna here for a moment. We try to look at the bacterial activity by measuring how much oxygen they respire and the rate at which they break down substrates. We are interested in bacteria because they are closely linked to the phytoplankton growth, more specifically because they feed on dead phytoplankton. We can go back to my colleague now.
In this one, we are measuring the enzymatic activity and how you do it. So we add a substrate with a fluorescence and we have enzymes that are going to break it, and if there is a enzymatic activity we are going to see the light. So in this one, if we see the light, there is an enzymatic activity. This one we are looking for there is or not bacterial respiration. How we are looking for it? So in those vials there's a luminophore which is detecting if there is or not oxygen. So how we know it? Because there's an inverse proportion between the light and the quantity of oxygen. And that's how you are going to know if there is or not oxygen respiration by the bacteria.
For measuring the abundance of bacteria and phytoplankton present on the samples, we used the flow cytometry technique. Samples were fixed in formaldehyde and frozen at -80 degrees Celsius. David here is explaining to us how flow cytometry works. The flow cytometry is an equipment that uses a laser to count every individual cell and analyze their size, shape, and properties. The machine contains several key components, including the sample, a laser, and a computer system to output the data into a form that can be analyzed by specific flow cytometry software. This gives us a good overview of phytoplankton and bacteria present in our samples.
Alright, after 7 days we're back from the field and we have our results. Now, we could give you all the boring statistics and outcomes we had, but for educational reasons, we will only stick to the most interesting parts and the striking results.
Yeah. Remember the chlorophyll A measurement we did earlier in our experiment?
Mm-hmm.
We thought out we found some striking observation. When we added nitrogen, we found that there was no effect on it.
Mm-hmm.
But when we did add phosphorus, we found out that the population of the phytoplankton quadrupled.
Okay, yeah, and if you look here, like if you add nitrogen and phosphorus both, the concentration octuples, which means 8 times.
Oh, 8 times. Well, here the water in value cement is phosphorus limited. You know, and when we also added herbicides, we found out that we had a negative effect, which is quite effective. We also found when we added antibiotics, we also had a negative effect.
Okay. Additionally, from the results from the flow cytometry, we can see which group of phytoplankton actually accounted for the positive and negative responses to different treatments. If you look here, the big increases in cell numbers for phosphorus and nitrogen and phosphorus treatments were for the nano phytoplankton.
Mm. Well, in contrast to our chlorophyll A result, another group of phytoplankton, a very small group called the phytoplankton, they doubled in cell number when antibiotics were added.
That's interesting.
Well, for the measurement of bacterial count and activity, the most striking observation was that the bacterial enzymatic activity and their respiration drastically increased when antibiotics were added. This is rather counterintuitive.
Yes, because if you would add molecules that are supposed to kill the bacteria, why would they increase their activity?
Well, a possible explanation for this would be maybe because the bacteria are stressed by the addition of the antibiotic and they kind of like react to it.
Okay.
And in a way, they kind of break down all of those molecules within the vicinity.
Okay. Or maybe if like a part of the community dies off, but another part which is resistant, is like they are thriving because they have extra nutrients because this part died off and they have like a big pool for themselves.
A big food. Okay, like in all experiments with students, some stuff goes wrong. In our case, we froze the flow cytometry sample in a freezer at -20 degrees, and the wave which would have frozen it at -80 degrees. Hence, the flow cytometry measurement should be taken in conscious.
A good lesson learned, I say. We have to think before we act.